Capacitors are fundamental components in electrical circuits that play a crucial role in storing electric charge. In this lesson, we'll explore how these devices work and why they're so important in electronics. A capacitor is a device that stores electrical energy by accumulating electric charge on two conducting plates separated by an insulating material. Think of it as a temporary battery that can quickly store and release electrical energy. The two plates hold opposite charges, creating an electric field between them. The structure of a capacitor is quite simple. It consists of two conducting plates, one positively charged and one negatively charged. Between these plates is a material called a dielectric, which is an insulator. The positive plate accumulates positive charges, while the negative plate accumulates negative charges. This separation of charge creates an electric field that stores energy. Capacitance is measured using the formula C equals Q divided by V here. C represents capacitance measured in farads, Q is the charge stored measured in coulombs, and V is the voltage across the capacitor measured in volts. Capacitance essentially measures how much charge a capacitor can store per unit of voltage applied across it. The capacitance of a capacitor depends on its physical properties, described by the formula C equals epsilon naught times epsilon R times A divided by D. Three main factors affect capacitance: the area of the plates, the distance between them, and the dielectric material. A larger plate area increases capacitance because there's more space to store charge. Conversely, bringing the plates closer together also increases capacitance because the electric field becomes stronger. A charged capacitor stores energy in its electric field. The energy stored is given by the formula E equals 1/2 CV squared, where E is energy, C is capacitance, and V is voltage. Notice that energy is proportional to the square of the voltage, meaning doubling the voltage quadruples the stored energy. This formula can also be expressed as E equals 1/2 QV or E equals Q squared divided by 2C, depending on which variables are known. Capacitors can be connected in two ways, series and parallel. In a series connection, capacitors are connected end-to-end, and the total capacitance decreases. The formula is 1 divided by C equals 1 divided by C1 plus 1 divided by C2. In a parallel connection, capacitors are connected side by side, and the total capacitance increases. The formula is simply C equals C1 plus C2. This is opposite to how resistors behave in circuits. Capacitors have numerous practical applications. In power supplies, they filter and smooth voltage fluctuations, ensuring stable output. They serve as temporary energy storage devices, providing backup power when needed. In radio circuits, capacitors work with inductors to tune and select specific frequencies. Camera flashes use capacitors to store energy and release it rapidly for that bright burst of light. These diverse applications make capacitors indispensable in modern electronics.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.